keep on repeating themselves in both directions forever? Exponential functions. What is an exponential function? It keeps growing, but what is it? I mean, like, that would be an example of when we would use them, yes. But what is it? Like, all exponential functions are some number, a, raised to the x. So like 2 to the x, 3 to the x, 1/2 to the x, 10 to the x. E to the x is a very special one, isn't it? We called it the natural exponential function. But what we have with exponential functions is that our variable is the power, right? As opposed to polynomial functions where the base is the variable. So here's e to the x, one of the most important functions in mathematics right there. Here's 2 to the x. Here's 1/2 to the x. So those are all exponentials. What are the log functions? They're the inverses of the exponential functions. So if I take e to the x and I show you natural log x, it should be its inverse. So when I graph it, it should be a reflection over the identity. Here's the identity line. Here's e to the x. Reflect e to the x over that dotted line, and you get the natural log. That's the property of being inverses. If I do the 2 to the x function, the inverse of that is log base 2. So that's its inverse. I'll take the e out of there. You see those two are reflections also. If I do the 1/2 to the x, then its inverse should be a reflection of it, right there. Log base 1/2. All right, now, knowing that, well, the fact that we've studied all those somewhere in the past, whether it be last semester or 20 years ago, we should all have some background with those functions. Now, transformations. If you know a function, okay, you're given a graph, you know what it looks like, then we can move it around pretty easily. If you take that function and you add a number to it, it moves it up. If you subtract a number, it moves it down. If you add a number inside the function, it moves you left. If you subtract a number inside, it moves you right. And you have to be careful with these, because these two right here are bass-ackwards, right? You know what I'm saying? They're opposite of what you think. I mean, adding C moves you up, subtracting C moves you down. That makes sense. Up, positive, down, negative. But for left and right, it's opposite of what you think. Adding doesn't move you to the right. Adding moves you to the left. Subtracting doesn't move you to the left, moves you to the right. Then we can shrink and stretch graphs by putting numbers in front. So if you put a number, a constant, in front of a function, then it will stretch it vertically by a factor of C when C is positive. If you put a number in front that's smaller than 1, like a fraction, like 1/5, it'll shrink it vertically. If you put a constant inside, then it'll shrink it horizontally or stretch it horizontally depending on the number inside. Then there's reflections. You can reflect over the x-axis and over the y-axis by putting negatives. So these are all things, again, in college algebra you should have done transformations. The only thing different right now is that we're talking about transformations on everything we've studied instead of just like trig functions or parabolas. So let's look at this one right here. And that is a quadratic function right there, parabola, right? That's just x squared. So right here, it's kind of hard to see that. Let me change this a little. See how this says 1 and then 1 plus x, or sorry, 1 times x plus 0 squared plus 0. Isn't this just 1x in here? So isn't that just x? Isn't that just x squared? Times 1 is x squared, plus nothing is x squared. So this is just x squared, right? So let me let me move it up. That would be a vertical shift, right? If I want to move it up, what would I do? So add some number to it, like let's say 2. So it should be a +2 right here now. And that's what it would do, right? It would move that whole graph up 2. What if I had done down 1? Right there, right? So this changing this number out here moves it up and down. Now let me change the number inside. So what would I do in order to move it to the left by 1? If I want to move this one right here to the left by 1, I would add 1, right? So I put a +1 inside. +1 inside moves me to the left 1. What if I wanted to flip it over? Change it to right here in the front, flip it over the x-axis, change it to a what? -1? Let's see. I may not have -1 there. Yep, there we go, -1. See, it's a -1 there. What if I put -2? What would it do? Instead of -1. It would still go down, right? But it would be narrow, right? It would stretch it out, shrink it. We would call that a compression or like a stretching or shrinking horizontally. I mean, there's different ways to say it. All I want you to do is, like I said earlier in class, if you download that player and you come in here at home, you can mess with all this and just see how changing numbers affects graphs, all right? All I'm doing right now is messing with the quadratic, though. I mean, we could do the same thing for sine, right? Take the whole sine function. Let's move it up 1. Let's move it up a half there, right? Let's move it to the, let's see, if I put -π/2, it's going to move it to the right by π/2. Right, I can flip it over. What did I do there? Did I just do that right there? See. Oh, I changed that. That changes your period. I didn't. This is wrong. Shouldn't say horizontal shift. It should be period. Let's see. Flip it over. So you can play with this on your own. Combining functions. Again, this is a college algebra topic. There are 4 operations that we learned in college algebra. If someone gives you 2 functions, right? F of x is this, g of x is this. You can do 4 arithmetic operations. You can add the 2 functions together, subtract them, multiply them, and divide them. But there was a 5th operation with functions. Do y'all remember it? Remember the fog? It's called functional composition. What's the difference between those first 4 arithmetic combinations and composition? What's the major, like, I mean, there's a fundamental difference between the two. What? Yeah, it's a function inside of another function. It's a function plugged into another function instead of a function plus another one multiplied. So you can have f go into g or g go into f. Like in this one right here, which function is going into which function? G is going into f. What if I wanted it the other way around? It would be called Goff. It would be g of f of x. Okay, so that's our operation. Now, let's see how we're going to do this in this class. So it's time to do some examples. So I'll do these on my page here. You'll notice how I'm kind of talking through these notes, right? And I said we've got those pre-class videos. That's basically what I'm doing, is I'm going through them, talking like I am now. If you watch that before you come to class, then all I'm going to do are the examples. And we will be able to do a tremendous amount of problems in this class if you do your part. If you walk in here and you don't watch any of it, you're going to suffer for that, because you're going to be like, I don't know what he's talking about. You know what I'm saying? The biggest thing, I think, in Cal 1 is you need to see as much as you possibly can, because there are so many tricks, there's so much algebra involved in this stuff that we don't have time to sit there and spend on me walking through this every class. All right? All right, let's get to these examples. I give you two functions. They are f of x equals x squared plus 1, and g of x equals x minus x squared. So let's find this first thing, f plus g of x. So what do you do when you see that? So you just add them, right? X squared plus 1, add to that what? Plus the other one, x minus x squared. And now you just combine like terms. So what would you get? Careful. Just x plus 1, right? The x squareds cancel. Now, what if we do f minus g? Subtract. So there's one thing we do have to be careful with here. What's that? That negative is actually going to have to distribute, right? So I should put the x minus x squared in parentheses so that I can distribute that negative through. So that becomes x squared plus 1 minus x plus x squared. By the way, we're reviewing right now. Have you all kind of picked up on that? Okay. So 2x squared minus x plus 1. Is it wrong if you would have written it, 2x squared plus 1 minus x? No, it's just we like to do things in descending order, but it's not incorrect to do it another way. All right, next one, fg. So f next to g like this is implied what? Multiplication. Bless you. So you need to put the x squared plus 1 times, in parentheses, the x minus x squared. And what do we call that when you do that thing? When you multiply two things like that together? What do you call that? When you go like from here to here, and then here to here, here to here, and here to here. Foiling is the cute name for it. What's the proper technical name for it? Expanding. It's called expanding. All right, so we're expanding these binomials. So x squared times x is x cubed, right? X squared times negative x squared is negative x to the 4th plus x minus x squared. Oh, we don't even have any like terms, do we? So I could leave it like that, or I could put it in descending order. I'm just going to leave it. What about division? What's that? The last one is 1 times negative x squared. So the next one, f over g, I think hopefully that's obvious that that's just division, right? X squared, or x squared plus 1 over x minus x squared. Now there's not a whole lot you can do with that, okay? There's not a whole lot you can do with it. So we could leave it like that. But I want to bring something up because, so many of you said you're going to have to take Cal 2. I want to show you that you could divide these two. I'm going to change the order here. Just flip the bottom around, okay? How can you divide two polynomials? You use long division. X squared, 1. Now, I left a gap in here. Why did I leave a gap? I don't have an x, right? So I just left a gap for any x terms. So that's x squared plus 1. I'm dividing that by what? Negative x squared plus x. How many of you have seen long division before? It's just been forever, right? Okay, so what you do when you have long division is you look at the first term here. Now everything has to be in descending order, which it is, and you ask yourself, what do you multiply